Good morning and welcome at GSD Idea webinar. Today we're focusing on the retrofits and on-site changes, modifications. Those are the situations when you design something, what very often seemingly is easy, but when facing the reality, it happens that it's not as easy to deal with afterwards. So this is the main topic of our session today. I'll be your today's host, Jan Barta, Managing Director of GSD Idea. And today with me, I have my two wonderful colleagues, Rose. Hey, Rose, how are you?
Hello, Jan. How are you?
Doing well, thank you. And we have also Venkatesh. Hi, Venki. How are you?
Hello, Jan. Good morning.
Perfect. So the three of us, we will guiding you through the very fascinating topic today. We're using GoToWebinar. If you have a question, you can ask it through the question panel. Otherwise, you're muted by default, so we can't hear you. So please type it, and we will be answering your questions during the session. After the session ends, we have a Q&A part at the end where we will be answering if there are any more questions left to go. So what can you expect today? Yeah, we'll be speaking about Idea Statica. Will it help structural engineers and civil engineers in the GCC? We'll be focusing on the RFIs and why they are a hidden productivity killers. Venki and Rose, they will show 5 real-life examples and how to deal with them. And as I mentioned, Q&A at the end. So let's kick it off. As always, we're just recapping why Idea Statica exists.
To comment on this slide, how much did the complexity of projects has changed in the last 10 years? We can see these numbers, 50 to 100% in the past decade. The complexity has changed. There's a demand, especially in this GCC region, on building higher, better, more complex, faster. And with that, you have to keep up with the environmental and sustainability complexity, the material complexity, safe, but at the same time innovate. So there's a huge demand on the structural engineers and how they use software and the technology. And it is necessary to keep up with these trends, to utilize the modern digital tools and optimize the workflow to allow to be as effective as possible. The world with Idea Statica. With utilizing Idea Statica's tools, engineers can dare to be creative without compromising the safety, productivity, or material efficiency. Structural engineers, we know because we are structural engineers ourselves, there's a high demand on us and we need to deliver. There is no room for an error. And very often the error happens on the other side, and then once again we need to improvise and deliver the solution needed in order to keep up with the deadlines and at the same time ensure the safety. So that's when Idea Statica comes in. Idea Statica is a company, Czech company, which focuses on solving problems of structural engineers with the innovative solutions. In these days, in 2025, Idea Statica is already in existence for 30 years, still keeping the innovative spirit. Now, customers all around the world perform over 16 million calculations. That's over done by 42,000 users. We're represented in over 125 countries in the world. And we are still a company of 120 employees, and with our network of resellers, very proud to be spreading the word of our solutions. Speaking of the resellers network, today here we're represented by GSD IDEA. GSD IDEA is a reseller here in the GCC, an authorized reseller, which represents, which is a wide variety of customers, over 490 customers. GSD offers technical support with IDEA Statica, also offers training and workshops. On top of that, implementation services and custom development. If you have a special need, you would like to optimize your workflow, if the words API, optimization, even Grasshopper, if these words are in your vocabulary and you need to help with them, let us know, let GSD know, and they'll be here to assist you. I have mentioned our customers. GSD customers are the innovative leaders within the field, and they are happy to be working with us. We offer them the technical support and try to take care of them, to assist them when they work on the demanding projects all around the world. IDEA Statica. What I have mentioned that IDEA Statica exists because of dealing with IDEA Statica's, with structural engineers' pains and problems. So what are the problems and what are the solutions? Complex connections. Complex connections can be solved with IDEA Statica, but not only that, everyday connections. There's a lot of them. So you can get rid of Excel spreadsheets and utilize IDEA Statica's workflow with parametric templates and utilizing Checkbot to have all of the connections solved within one tool. Also anchoring. This is very complex issues when you need to anchor the steel structure to the concrete foundation, and when you need to take into consideration the reinforcement, which isn't very covered in the codes. This is where IDEA Statica steps in. With that, concrete discontinuity regions, we not only focus on steel, but also on concrete. And last but not least, the stability. My professor in the university always used to say, he was a professor of concrete design. He used to say, steel is great, but it buckles. Exactly. Therefore, we need to prevent it from buckling and need to check the stability. This can be also solved with IDEA Statica. And again, BIM workflows. We don't want to do the repetitive over and over again. We want to exchange the information efficiently. That's why we have our BIM workflows in our portfolio. Believe it or not, you can save up to 23% of the whole project time by utilizing IDEA Statica. You can save 8% of the materials of the whole project, because when over-designing a connection, this is what happens. You over-design and there's so much more material than needs to be. And most importantly, you can be safe, and you know that the design has been done and there doesn't have to be any oversimplifications in your design. But let's look at the agenda of today's webinar, and which is the everyday connections and on-site adjustments. We all know it. I wish I had a project where I design, I turn it in, and this is it. No, there's always the call from the job site that something has went wrong for various reasons. There are misaligned holes, wrongly installed anchors, collisions with other elements, notches and cuts in the plates, and just any unexpected elements or a human error. All of these can happen. There's probably no avoiding it, but luckily there's a way how to deal with that, and that's by utilizing IDEA Statica. And not to scare anybody, we need to cover these problems in order to prevent any catastrophe, as it happened in 1981 in the Hyatt Regency Hotel in Kansas City, where a small detail was the cause of of such a huge error. And you can see there was only a misaligned railing and compromised the safety. Such a small detail, small error, and it has caused a giant issue. But we don't want to do that. We want to have a look at it, and we want to cover it. And I wish there was Idea Statica back then, so they could solve it and prevent this issue. But there is Idea Statica today, and which lets you do complex connection, because even a simple connection, when dealt in the simple connection tools that are available, but when there is a change, when there is a misalignment, when there is a notch, how a simple connection, relatively simple connection, can become a complex connection, and it can lead to a lot of hours. And on top of that, this time you don't have, you're already thinking about the next project or something else, and all of a sudden you need to come back, realize what is happening, get back again familiar with the old project, and start designing again, and you very often compromising. So let's have a look at it. The time of 8 hours can be solved in less than 30 minutes, as we will see by demonstration from Venkatesh and Rose. And you can be up to 16 times faster, and you can make the model adjustments, run the analysis, report, and send for an approval once again. So right now, I would like to run a poll, and I would like to ask you, on average, how many on-site changes do you typically encounter during your project? I'm launching the quick poll right now, and I'll wait a little bit for our attendees to vote. Right. Okay, 80% of the attendees have voted. So I'm closing the poll, and I would like to share the results, and we can see that basically having zeroed on-site modifications, nobody has encountered that. 75% of you encountered 10 to 50 times, which is already a lot, and then 51 to 150. That is incredible. Like, you have to spend so much time on these adjustments. Okay, without further ado, let's have a look at it. This poll has made it clear. Now we want to have a look at the real thing. Venkatesh, are you there?
Hello, Dominic. Yes, I'm there.
All right, please let us go through, show us what you can do with Idea Statica. Let's have a look at your designs.
Yes, initially, thank you for sharing the information, brief information about the introduction and everything. Let's see some practical. Let me share my screen. Dominic, can you see my screen?
Yes, I can see study case.
Thank you. Thank you for confirming. So let's see some of the practical, not practical, realistic examples in our workflow. There is a case where there is a braced column. Obviously, the bracing is framing into the column, and it was connected to the base plate and framed into the concrete pedestal or footing. So it was perfect design and submitted along with the reports to the client, got approved, and we have a set of perfect fabrication drawings, and it was fabricated, and again now it was transported to the site for erection purpose. However, despite being perfect design and perfect drawings, site conditions are never 100% predictable. So let us discuss further on what happened to this perfect connection. So we got a query from site saying the highlighted bolts cannot be installed. So after investigating what is the reason for it, we got to know that the concrete block was there at the location of the bolts, which was preventing from bolt for the insertion and tightening at the site. So it was an issue which was highlighted from the site team. So what we have to do is we cannot do anything about it, and we have to provide a solution by keeping a note that to avoid any fabrication reworks. So obviously fabrication reworks causes a lot of money in the overall project cost, which is not desired by anyone. So the ideal solution would be to reevaluate the connection as per the exact site condition, which is to check the connection again, reevaluate again based on the existing condition. So to reevaluate this connection with existing site condition, let's see some of the design parameters what have to be checked. So I have to recheck the already designed connection with reduced number of bolts. Initially it was designed for 8 number of bolts. However, in this case 3 bolts cannot be installed at site because of the concrete block obstruction. So I have to recheck the connection for only 5 number of bolts. And also I have to consider the reduced cross section due to previously drilled holes in the tongue plate. Tongue plate is nothing but the plate which is protruding from the brace, and also the gusset. We already have the holes drilled, so cross section is reduced. So we have to check the reduced cross sectional strength of the plates. And also we need to consider the eccentric loading since bolts are not symmetrical. As you can see, the CG of the bolt group will lie away from the member CG. So there is a chance of, not a chance, it will be, the eccentric moments will be generated. So which we have to consider in the re-evaluation of this connection design. So if you are using a manual template in this case, like MathCAD or an Excel sheet, we have to spend a lot of time to modify the template in order to accommodate all these considerations in the template. However, in Ideastatica, it makes it easy for you, like modifying all these changes and considering all the design considerations, like considering of center of like the eccentric loading and everything. It's easy in Ideastatica. Let's see how easy it is to make the changes in Ideastatica to resolve this site query by matching the preliminary design with existing site conditions. Let me open the file for you. So here is the connection which was previously designed in Ideastatica. Now, because of the site concerns, we have to update this connection to match all the operations and everything with respect to the site, existing site condition, and re-evaluate the connection. So first I have to, like, the top 3 bolts are not possible to install. The insertion and the tightening of it was not possible because of the concrete block. So I'll do that first. I will just go ahead and delete the bolts. In order to delete the bolts, just select the bolts, go to editor, go to the tongue plate option where I can see all the bolts. I can press explode, as you can see on the top right, and I will delete 6, 7, 8 bolts. Eight, delete, delete, and 4, delete, apply. Okay. Oh, sorry. It was on top, so this was not the location of the bolts. Let me go back. I can always press undo button to undo the operations which I have done in the connection. I'll go back to the editor. and I will press the explode, where I will delete 1, 5, 6. Apply. Okay. Yes. So the the bottom three bolts which cannot be installed at site are deleted now from the model, as you can see. But that is not the only thing which is to be considered in the design, in the reevaluation of this connection design. We have to also add the holes which were previously drilled, because the plate is already at site. So, and the holes will reduce the capacity of tongue plate as well as the gusset plate. So we have to consider the reduction in cross-sectional area as well. So in order to do that, click on the tongue plate. Again, go to the editor, go to the tongue plate. You can see more detailed information if you go to the drawing here. So all the spacings and everything will be visible. And on the top left, you can see the operations where you can modify the plate, which was shown here. So my current goal was to add holes, additional holes. So there is an option called hole here. I will click on it, and a circle of diameter 16 mm. And assume this as a simple graph which you will work with X and Y axis. So that's my monology. You can try to use that. It's very simple to move the operations in the plate. For this, I will give X axis to be -210 and Y to be -30, which is, if you add the dimensions from 40, 55, 55, 60 is nothing but 210. So the origin of axis is somewhere here. So from here, 210 I gave, and Y axis -30. That's it. So I will just copy this operation without creating a new operation, because I need another row. I will make it opposite side of the axis with +30, and I will copy it again. Instead of -210, I will give -150. So that's it. Holes are added in the tongue plate. So cross section was reduced here as per the existing site condition. However, I also have to reduce the area in gusset as well. In order to do that, go to again editor, go to the gusset, again go to the hole operation, in which I need again 16 dia of hole, and the dimensions to be 127 in the x-axis and 71 in the y-axis. And copy next hole, 89 x-axis, 117 y-axis, and the third one 135 and 156. So it was nicely arranged. This is what we want to match exactly with the site condition. As you can see, it's a see-through, so no material is there, and it was perfectly notched in both of the tongue plates on either side and as well as the gusset plate. So that's it. It's done, your process. Only thing left was to analyze it, which I just pressed. Give it a minute to analyze the connection. And it's done. So as I can see, the utilization ratio all are within limits, and it's fine. Like we can say that you don't need to modify anything in the site. You can leave the 3 bolts as it is. No need of any modifications. Only 5 bolts are enough to transfer the force from bracing. So no further changes are required. I can take a report successfully and submit it to the client for reapproval of this site condition, and this query is done. One more tip for all of you, like most of us will send a reevaluation of connection design to the client along with a detailed sketch identifying what are the changes done in the connection. In order to do that, you don't have to prepare a sketch by yourself. In Idea Statica, you can extract a cross-sectional view by just clicking on the member, right click and create section, where you can see the 2D information. Like you will have some blocks like this. You can just expand it like to create the view. once the block is highlighted, I'll just drag it here. Yep. So give me a second to adjust this. Yeah. So we have the 2D cross-sectional view with all the informations which were there in the uh, connection. However, I'm not interested in all the information about the plate thicknesses, weld sizes, and the dimensions, because this is an existing connection and it is as per the dimensions in the site. So to send to the client, I don't need all this information. So I just need a bolt information. To do that, I can go to the top here. I can see this symbol where I can switch off the dimensions, I can switch off the part information, I can switch off the weld information. Only the bolt information was there. And I can take a picture of it from new, which will be saved to the gallery. And I can go to the report and I can include the images, take it from the gallery and generate the report. So that's it. We hardly spent very less time in order to do this calculation and submit it to the client for reapproval. It's very easy process. However, in the manual calculation, you have to update your entire template, which is not an ideal solution considering the busy schedule in the projects and everything. Okay, and instead of completely redesigning Idea Statica, validating the real condition effectively saves time, prevent project delays, and ensure safety. With that note, let's move on to the case 2, where we have a similar baseplate connection, but not a braced one. So in real construction, generally anchor bolts often shift during concrete casting. In some of the cases, we used like people who design this used to give big slotted holes, and provide a uh, slotted holes in order to accommodate these shiftings and all. However, it won't be done in all the cases. So in this case, there is a issue with the matching of the anchor coordinates along with the bolt coordinates, and column base plate cannot be placed on the anchors correctly. So this might happen due to the miscommunication between the concrete contractors and the steel contractors, where the concrete casting and the anchors are in the scope of concrete contractor, and the steel base plate and the steel column is in the scope of steel contractor. So here, to resolve this issue, a straightforward and simple solution was to drill new holes and recheck the connection. And also, as the existing problems are not enough, we also have a bonus problem, which is a concrete obstacle here, as you can see, which will prevent the base plate to have a flat landing on the concrete. So we have to locally notch the base plate in order to have properly installed at the site. So coming to the design checks which has to be performed, we have to check for the unsymmetrical placing of the anchors, as well as the reduction in the cross-sectional area of the base plate for already drilled holes. And also, because of the notches, some cross-section will be reduced. So we have to completely re-evaluate the connection by all these site conditions in a already designed connection. So let me just open the file for it. So this is the initial design where we have a column base plate connected to concrete footing or pedestal, and it was fine. So now we have to update this connection in order to match with the site conditions. In order to do that, first I will offset the anchors to the existing condition in the site. So I'll click on anchors. I will go to the editor. Again, the BG1 group represents the anchor group where I will explode it to make further changes. and I will offset as per the site information. So 165 axis and 165, so 165 minus 225 minus 225. So I have offsetted the anchors to its exact position as per the site requirement. However, I have to create the holes which were already drilled in the existing base plate. So I will go to the again hole operation, which how we discussed in the previous case. So the diameter of hole to be 20 mm and the offsets 195 and 195. I'll just copy the operation again and I will change the direction minus 195. Copy it again and minus 225. Sorry, minus 195. And the fourth one, the last one, minus 195 and 195. The fourth one, five, and yeah, so done. All the holes are placed properly. So in this, I have considered as per the existing site condition, the offset of anchors, which will result in eccentric loading and all. All the effects are automatically considered in the ID Statica, so I don't have to worry about what is the lever arm and how to resolve the movement into couple force and all that. It's all, everything is automatically considered in ID Statica. And in addition to this, we also have an obstacle here. So I have to notch the base plate, which will obviously reduce the area of the base plate and also its strength. So in order to model the notch for this case, I have added a hole in which diameter I will give it 120 and offsets minus 250 and 40, and I will just copy this and offset it by minus 50. So I got my notch. It's very simple. So this kind of notches, it's difficult to analyze. Like we can't even use the manual spreadsheets in order to exactly predict how the behavior of the base plate to be, and only to analyze this kind of behavior we have to use the FEA applications, which needs deep understanding and high skill for it. So with ID Statica you don't need to have uh, that much level of knowledge in FEA. You can directly model the notch and check the connection. I press the calculate, just give it a brief moment to analyze. Oh, it's already done. So we have the connection passed and we have a lot of reserve strength as well. So notching is fine, offsetting the anchors is fine. So only thing I have to do inside was to drill the new holes and place the anchors accordingly and resubmit the report for reapproval. So that's it for the case 2. So key takeaways for this example was site modifications should never be approved blindly. With ID Statica, checking real conditions becomes fast, safe, and also practical. Let's move on to the third example, where it's a simple shear connection, a beam framed into the column with a fin plate, and the main concern of it was misaligned bolt holes. So this is a very common site query, which we used to get in a lot of projects, and it's very common in modular construction, and even small fabrication tolerances can cause bolt alignments. So keeping in mind that not to refabricate or rework the existing connection. The simple solution was to site weld the fin plate with the beam and close the design and allow the site team to work accordingly. So in order to do that, design challenges were to consider the C weld, the weld between the fin plate and the member web, and recheck the C weld, and also check the fin plate and also member web for the reduced cross-sectional area. So without any delay, let's go to the Idea Statica model. As you can see, this is the source design of this connection, which was beam framing into the column with a nice fin plate and bolts. However, site conditions are not allowing us to follow this connection design. So to match the connection design as per the site requirement, a site conditions, I will just go to the editor of the bolts again, and I will explore the bolt group, and I will delete all the bolts. Apply. Okay. So bolts are gone. However, I can't leave it as it is. There are holes in the fin plate as well as the member web, which were already drilled to accommodate the bolts, which have to be considered in the design, which will result in the reduction in the capacity of the plate and the member web as well. So we must consider that in the design. To add the holes in the plate, I will go to the editor, and again in the operations tab, I will go to the hole, a circle, and the diameter of it I will give to be 20 dia hole, and 0 axis, I needed it center, so, and 120 offset in the y axis. We'll just copy the operation 60. I will change to 60. I will copy, I'll put a hole at the center, and minus 60 and minus 120. As you can see, it's as simple as that to add the holes. And related to the member, we can't add holes in the editor. To add the holes in the member, we have to go to the operations as highlighted in the design tab. We click on the operations, and we can see an operation with an opening and notch. Click on it, and here we have to choose the member in which the notch should be. So if you're not sure which cross-section part to be selected, you can just go to the cross-section where you want the holes, and on the left bottom side you can see the description about it, what part it is, like B web 1. So cross-section part, I will choose B web 1, and I need a circle. Yes, I can choose other shapes, but for this example I need a bolt hole, which is a circle. So circle, and diameter to be 20 mm, and X position is I will give 37 and it's 120. So I can see a hole now in the member as well. Obviously the issue is because of the misalignment, so obviously it should not match here, the holes. So I modeled it accordingly as per the site condition. So I will just copy this operation again. I will change from minus 120 to minus 60. I will copy all the operations for the rest of the whole location. 0 and 60 and 120. So done. So reduction in the area of the fin plate and the member web are done. So one more operation was balanced in this, which is to add the weld. For that, you can go to the operations and select the weld operation and choose the plate option, or you can also drag down and select the plate, and the second plate to be the member web. So the member option, and you can also click the cursor and choose the face. After putting that, I can see the indexes, like I need C weld. So on 1, 2, and 3, so local edge index, I can press 1 space 2 space 3, so that weld will be modeled here on as a C weld. And I will give the size to be 5 mm. for this case. So let's see in a 3D view. So as I can say, it was modeled nicely. This is the way I wanted. So the seawell was modeled between the film plate and the member web. So without any further delays, let's analyze the connection. Well, it is within utilization ratio, so therefore I can again go to the report, extract the report, and submit it to the client for the reapproval. That's it. Even so, key takeaway of this case was even when Bolt installation fails, Statica allows us to adapt and validate a welding-based solution easily, helping avoid costly project delays. Yep, so that's it from me for the day. Rose, can you please take over for me?
Yes, thank you so much, Venki, for the detailed description of the cases. Can you please confirm if you can see my screen? Thank you so much for the confirmation. So without any further delay, let me start with the fourth one in the series. That is when there is an increase in load suddenly, maybe due to the change in usage after a certain years of time, or maybe due to change in framing, that is removal of a beam or a column or addition of the same, or due to obviously building expansion. Now, what should happen at first? Now, at first, you will need to modify your global structure and make sure that your member is safe with the changes. Now, once the member is tested and proven safe, the next step for the designer is to carefully make sure that the connection that he's going to perform would be safe. Now, let me just quickly demonstrate the same. Now for that, I'm opening a blank case just so I know that this could be a case that the designer might have dealt with 10 years or 5 years ago. So he might not have the Idea Statica file with him at this point of time. So I'll start with the same scenario where he would be in. And if by any chance you have a query on the materials, because a few years before, the materials that you've used for this particular connection, if this is not the materials that's currently available in Idea Statica, then there is always an option to go to the materials, edit the materials to the type of materials that you want that would resonate the exact connection, and then continue with the connection design. Now, I've inputted the loads which was already there in the existing structure. I'm asking for a proposal from Idea Statica so that I would get. I'm looking for an in-plate connection, just like how I have it in my workplace. I'm keeping the defaults be defaults, just so I know that I can change the operations at any point of time. I'm giving a bit of change to the thickness. I'm giving 10 for the thickness. I'm changing the dimensions a bit, basically readjusting the dimensions to match with my site conditions, changing the bolts, the top layers, and the left and the right layers as well. And I'm keeping the welds. I need it to be double fillet weld, and I would need the throat thickness to be 5 and 3 for the flanges and web. Now, once I've made the necessary changes, I'm going for the calculation. And here I have the calculation for the existing structure. Now, the real task of the designer, that is to change the load, that is to redesign the same structure for the modified load. I'm changing the loads 10 to both shear and the moment, just so as to adjust the column, to balance the column. I am doing the necessary modifications to the column as well, and I will have -13 here, and now I can see that it's completely balanced, and my connection is ready to be analyzed with the existing loads. Now, with the way that it is calculating, I have an idea that it's going to fail. The components are going to fail, but still, I want to know what exactly is happening while the analysis, where exactly the failure is happening. Now, to check that, I am going to turn on the plastic strain, mesh, and the deformed shape, and now I know where exactly my failure position is. I need to strengthen the web a bit and the portion right on the top of the bolt as well a bit. Now, to do this, I have to provide an operation of first things first. I'll go with the doubler on the web. For that, I'm using the stiffening plate operation. I'm providing that on B and giving it a thickness of 6. And I need to be rectangular. I have the dimensions required. I don't need it on the origin, but I need it on the member. C, but not on the bottom flange, but on the web. I need it as a doubler on both the sides, and I definitely go for a one side fillet weld. And now I'm analyzing the connection again. And my results are here. I have the plates safe, I have the welds safe, but the bolts are still failing. And I know what exactly is the reason for the failure. And as I explained earlier, I need to provide a support to the beam so that this portion would be a bit strengthened. Now for that, I'm providing another operation, which would be the rib operation. And on the rib, I am keeping it on member B. It would be on C, and thickness, I'm keeping it as 10. I have a width of 200 and a depth of 100. I need a chamfered one. I need it on the bottom flange, and I only need it on the lower surface. And I'll just keep, just to be on the safer side, I'll keep the wells to be 5. And I'm calculating it again. And yes, I have a plate clash warning right over here. Now, for that, all I have to do is to just go to the editor, create a notch on the editor, and I can provide the values for the notch, which would be 15 and 70, keeping the radius as it is, but the right corner would be 5 in this case. Now, how do I know? I can just keep it aside and check it right over here. I can just apply it, and then I can see that the clash is already disappeared. Now apply it and then press on OK. I'll run the analysis again. And yes, I can see that it has already passed, but I can also see that the plates which I provided at first are underutilized. So in that case, I might not need this plate for the retrofitting. Changing the plate, and I'm running the analysis again just so that I can save material. And I have the results in here. Now, this would be the first example on the series, the fourth on the series. Now, moving on to the fifth one, which would be on-site interferences. Now, this is a very common issue during construction phase of a project. I'm quite sure that we might have encountered this at least once, and it's very common that unexpected elements or clashes with the structural members like pipes or ducts passing through beams or stiffeners. Now, most of them in most of the scenarios are inevitable, and the designer needs to verify that the structure is okay with the modifications. Now, to demonstrate this, I'm taking a simple moment connection, and now I have the stiffeners in here. I have 4 stiffeners on both the sides, but the primary instinct of me as a designer who is working with Idea Statica, if I have a modification on any of the plates, would be going to the editor and providing an opening. But the problem in here would be that if I am editing one stiffener, then it would affect all 4 stiffeners. Now, how do I counteract that one? Now, for this, I have a wonderful operation, which I would say is a very underused operation by most of the engineers, but this is a very useful operation at the same time, which is called as the in volume. that is a negative volume. You might have already heard about it, known about it, but this is how we use it. And the best part is that we can provide the negative volume as a member, and I've provided it as a cross section, a circular cross section, and I have provided the length of the member such that it would cross both my stiffeners, and I can just do the cut in just one operation. I'm providing the cut as P-cut 1 with the surface, and P-cut 2 with again the surface, so that I have the cuts right at where I want. If you can see that the cut is right over here, but it's not in here. Now, what if I need one more modification on, what if I need a circular arc on this beam? Now for that, I'm providing another negative volume, the same way that I've provided in here. All I have to do is to just adjust the offsets of the negative volume so that it would exactly replicate the site condition. Now, once I have the in volume in my place, all I have to do is to just cut it and then run the analysis so that I know that where exactly the failure of the beam would happen. Now, once I know where the failure of the exact or the location of the exact failure is, I can do the retrofit as I need it. Now I can see the plates have failed. If I go to the check tab and the strain, mesh, and deformed shape, if I scale it to the real scenario, then I know where exactly I need to retrofit. Now with this, I'm ending the 5 series, the cases that we have. I hope, Jan, are you still with us?
Yes, I am. Thank you, Rose. I'm sharing my screen. Let me check that I'm sharing the right one. Thank you very much for being with us, even through my technical difficulties. My laptop froze 2 times during this presentation. So Rose, if you can just quickly confirm that you can see my screen.
Yes, we can.
Perfect, thank you. So we will be wrapping that up after those 5 examples. So what you saw is that Idea Statica can, with Idea Statica, you can accurately and quickly model a connection, including the components as they were fabricated. In real life, you can include the effects of holes, notches. If you're retrofitting, you can easily iterate to get to the design that you actually need. Then click of a button, quickly analyze, assess if the connection is passing all the checks, generate the report, and approve. 3 steps, very fast. In the end, you could see that both Venkatesh and Rose did it in a matter of a couple of minutes. So this is actually a safe way how you can save up to 94% of the time on the process of in the beginning looked like a very simple connection, but in the end ended up as a complex. Before we wrap it up completely, we have one more poll that I'm now launching. So please go and vote. It has 2 levels. If you're already using Idea Statica, let us know if you're using it. If not, let us know that the retrofitting and the on-site changes with Idea Statica that you would hypothetically use would bring you a benefit, or you're still not sure. You believe that there could be some things that could be still answered, explored, or you just don't believe that Idea Statica will help you, or the retrofitting or on-site changes are just not the case. So a few more seconds to end up the vote. And it's very surprising. It's very surprising. I'm closing the poll and I'm sharing the results. So it's a very good feedback for us to hear that either you're already using Idea Statica and it helps you, and if you don't, you believe that you will speed up your process. So thank you very much for confirming this. let me hide the results, and I have just the last slide with the next steps, what you can expect. If you missed that information, last week Idea Statica released version 25. It's packed with a whole bunch of features, even updated applications. If you want to speed up your design, there's more than 200 parametric templates that really lightning speed for your designs of both simple or those complex connections. You can calculate anchorings considering the reinforcements in concrete. Now with ACI code checks, there's improved BIM-link with Tekla, so you can now transfer the anchors well. So that's a good news for all Tekla structure users, or you can just enjoy the improved and really sleek design of the launcher app. So go to Idea Statica webpage. On the homepage, there are all the instructions, release notes, link to download, videos. Definitely go and install version 25. The next week we're live in Abu Dhabi, so feel free to register for this event if you want to meet us. And not just us, there are also customers who will show their angle on Idea Statica, their projects where they used Idea Statica, and share how they benefit from using it. It's a May 7th, Wednesday. The only thing, please do let us know that you want to be there through info@GSD Idea, as the spots are limited and there's only few of them left. And the last but not least, GSD Idea is here for you to make sure that you maximize your investment on Idea Statica. Having the technology is one thing, but actually implementing it in your workflows takes some effort. So this is why we are here. Register for a regular onboarding training as a customer. It's complimentary. If you need to take it to the next step through workshops, they're tailor-made, hands-on. This is what we can do for you as well. And if you need to take it even further through API improvements, automation, parametric setups, let us know. This is all what we're doing for our Idea Statica customers. With that, let me thank you for being with us again, even through the technical difficulties. Since we're already exceeding the dedicated time and we covered all the questions online, we will skip the Q&A section, and in case you have one, feel free still to place it through the question panel and we will be answering it offline. So with that, thank you very much. Thank you, Rose. Thank you, Venkatesh. Thank you, Dominic, for saving me, and see you at the next event. Take care. Bye-bye.
Thank you, everyone.
Bye.
Bye.
Thank you.
Bye-bye.